In the last class, we discussed Boolean algebra. So, in order to simplify the Boolean equation. So, this class we will discuss Karnaugh map, or we can say it's a K map. Karnaugh is the name of the person who introduced. So, in this K map, this is an alternate method, as I said, for the Boolean algebra. So, in this K map, for example, which contain 2 to the power of n number of cells. So 2 to the power of n cells means in this n is number of input variables. Number of input variables. So in this case, for example, if I say it is having only one variable, then 2 to the power of 1 means 2 cells is enough. If the number of input number of variable 2, then 4 cells required. If it is 3 input variable, then 8 cells required. If there is input variable is 4, then 16 cells required. If the input variables are 5, then we need an 32 cell K map. So according to our syllabus, we will reach maximum of 5 variable K map, not more than that. So in this case, in any K map, there should be only one bit change should be there. Only one bit change should be there in the adjacent cells. I mean to say, here is 0, 0 means here it should contain 0, 1 and 1, 0 and 1, 1. Only one bit change should be there. This is the 4 cell, not a problem. If it is 8 cells and 16 cell, there should be a problem. So that's why instead of using in this place, instead of using the binary code, we should use a gray code technique. Gray code technique, why we are using in K map? In order to make a 1 bit change in the adjacent cell or the neighboring cell. So for that reason, we are using gray code technique. Now we should see how to convert the binary code into a gray code. And binary code is a weighted code and the gray code is non-weighted code. For example, if I would have written a 2-bit variable, means 0, 0, 0, 1, 1, 0, 1, 1, this is the binary combination. Similarly, if I want to convert this into an equivalent gray code, it is pretty simple. So 0, 0, so this is the binary number. I am showing that how to convert the binary number into an its equivalent gray. 0, 0, so I should place 0, 0. First position I need to retain as it is. Then I need to XOR this position with the next position. 0 XOR with 0. So I am getting 0, 0 only. Its equivalent gray is 0. So this is the gray. So this is the first one. Similarly, next we will see for the second combination 0, 1. This is for the binary. Again, first position I will retain as it is. Then I will do the XOR with the next position. 0 XOR with 1. So 0, 1 only. So again for the gray, I am getting 0, 1. Similarly, for the next combination, I will take 1, 0. So this is the binary combination. For the gray combination, first position I will take as it is. 1 XOR with the 0, I am getting here 1. So for 1, 0, the equivalent gray is 1, 1. For the last position, for the binary, it is 1, 1. Its equivalent gray is, so first position I will take as it is. 1 XOR with 1, it is 0. For the 1, 1 combination, I am getting here 1, 0. This is the one method. The one more method is there to convert the binary to the gray. This is the first method. Second method we will see that, see for example, I will take this number. See 1, 0 is there. This is the second method one which I am showing. See 1, 0 is there, I will take. So what we need to do, take the number. Okay, this is the binary number. This binary number, take one right shift, 1 bit right shift, then I will write this is 1, 0. And try to neglect this. Then 1, this I need to assume that 0. 1 XOR with 0 is 1. 0 XOR with 1, and it is the equivalent gray code. Similarly, if I am doing for the 3-bit number, for example 1, 0, 1, 1, 1, this is the binary. What's its equivalent is 7. See, if I want to convert this into a gray, so in the second method, first position I will write 0, 1, 1, 1. Then I will take 1 bit right shift, 0, 1, 1 and 1. So again I will neglect this, I will take only this 0, 1 XOR with 0 is the 1, 1 XOR with 1 it is 0, 1 XOR with 1 it is 0, then the 7th equivalent is the 0 1 0 0 is the 4, gray of 4. Similarly, this method, the first method also we will see that for the number 0 1 1 1. So for the 0 0 1 1, what we need to do? So 0 I will written as it is, 0 XOR with 1 I am getting 1, 1 XOR with 1 I am getting 0, 1 XOR with 1 I am getting 0. See, in the either the method we are getting the same gray code. This is how we are going to be converting a binary number to gray code. So now we learned how to convert the binary number to a gray code. So now what we need to do? First we will see how to make the mapping and the grouping of two variable. Now I will take two variable K-map. In the two variable K-map, it's having 2 to the power of 2, we need an 4 cell. Two variable means I will take A and B are the two variables. So in this, what I will do, I will take a 4 cell K-map. This is the 4 cell K-map. In this 4 cell K-map, this side A comes into the picture, this B comes into the picture. See, the combination of this AB, two variable, it is 0 0 0 1 1 0 1 1, isn't it? So this A is, for the first two combination, A is constant and only B is varying. Second combination, only A is constant and again B is varying. So what I will do, so this side I will take A and this side I will take B. Then when A is 0, so B is once it is 0 and once it is 1. Similarly, when A is 1, again once B is 0 and once B is 1. Now, if I take, this is the position for 0 0 and this is the position for 0 1 and this is the position for 1 0 and this is the position for 1 1. Correct. So I can say that this is the 0th 1, 2 and 3. Correct. So this is 0, this is the 1, this is the 2 and this is the 3. Correct. This one I have mapped here. So after that, even we can represent with them variable. This I can represent with A bar and this is only the A, and this one I can represent with B bar and this is only the B. For example, sometime if we are getting like this, for example, equation we may get y is equal to A bar B plus AB plus A bar B bar. You may get like this equation. So this equation, how to map into this K map and how to simplify this equation. So now what I will do, so whichever, see A bar B I want, A bar B, here I am getting 1. The next is AB, A is there, B is there, here I will place 1. The next one is A B bar, A B bar, here I am getting 1. And whichever the place we are not getting, we don't have a term, so there I am replacing with 0. So this one we shouldn't consider for our grouping. And one more thing you should remember, in a group, as a number of cells increases, the variable in the term keep on reduces. Once again I will tell you, as a number of cells increases in the group, the variable in the term is keep on reduces. That we should remember. And also we should make the less number of group, obviously the number of terms in the equation get reduces. So now I need to do an grouping. So this is the one group. This is my first group. So in this group, so what is the equation? Y is equal to this group. A is changing, so that's why we shouldn't consider, but B is constant. I will take the B. One group is over plus. Next, the next group, if I do all only this, so I am getting two variable A B bar. If I do grouping with neighbor cell, so then this is the second one. So what we are getting here is, see here B bar and B is changing, only the A is constant, we are getting only the A. So this is the simplified one. So like that, we may get different or the several situations. Similarly, if I talk about, so this is the 4-cell K-map. Okay, here this is called pair. This group is called a pair group. So this is the pair. Suppose sometimes what may happen, there may be a chance of getting all ones. In all the cells we are getting 1, 1, 1. So that time we should group all the cells. This is called quad grouping. In this quad grouping, if all the cells are covered, so we should say y equal to 1. Fine. And sometime there may be a chances of the don't care conditions available in the truth table. How exactly it is, I will show you that. For example, I will take one example. So this is the truth table. This is the truth table. In this truth table, there are two variables, A and the B. And this is my Y. So 0, 0, 0, 1, 1, 0 and the 1, 1. Here, I may get 1 don't care condition, 0 don't care, 1, 1 I may get like this. So what it don't care indicates? This don't care indicates we can consider this don't care as 0 or 1. Now we will see that. First I will place the K-map, 4-cell K-map. So in this K-map I will take A and B, and this is 0, 1 and 0, 1. And for the 0, 0 combination, this is 0. For the 0, 1 combination, this is the don't care. For the 1 combination, this is the 1. For the 1 combination, this is the 1. See, in this scenario, see, we can consider this don't care either 0 or 1 according to the situation. Fine. Now, in this situation, I won't get the chance to group with don't care. Why? Because here I am grouping this 1, 1 I am grouping here. So now no need to group with this because don't care. Either now in this case condition I am considering this as 0. So why? Because in my final equation I need as less number of terms in the final equation. Okay. So in that case I will take y is equal to only a. Some situation comes like this. For example, so in this case, in the last case, instead of 1, 1, 1, I may get here, this is the one condition. Second condition, so I will write the second condition scenario. In the second condition scenario, here I am getting A, and here I am getting B, and here I am getting Y. So this is 0, 0, 0, 1, 1, 0, and the 1, 1 combination. Now I will take this. In this case, here I will take 0, and here I will take 1, and here I will take 1. In this place I will take don't care. So in this case, how to draw the K-map? See, first I will draw the K-map. This is A and this is the B, and this is the A bar A and this is the B bar B. In this scenario, see, this is the 0th place, this is the first place, and this is the second place and the third place. Here I need to mapping. So first I will do the mapping. The 1 here 1, and this is the don't care. Now I need to do the grouping. So in this situation, if I am not consider this don't care, if I group this one and this one individually, I will get two variable term. So instead of that, what I will do, so for this situation, I can consider this as 1 instead of 0. So that's why I am telling don't care we can consider either 0 or 1 according to the situation. In this situation, I am considering this don't care as a 0, but for this condition, I am considering this don't care as 1. So why I am showing you is, if you get the don't care, how you to group using don't care. So now I am grouping this. So this is my first group, and I am getting y is equal to b plus, and this one I am grouping, then I am getting B bar B get cancelled, only A I am getting. So this is how I got the final equation. If I would have not considered this don't care, instead of one variable I am getting here two variable, here again instead of one variable I am getting the two variable. As number of variable increases, obviously we all know that the propagation delay of the designers keep on increases. This is what the general introduction of the two variable, the K-map mapping and the grouping. Now we will see the three variable K-map and its grouping. Now we will see the three variable K-map, three variable K-map. So in this three variable K-map, 2 to the power of 3 is 8 cells were required. So 8 cells, in this case we need to take A, B, C combination. It starts with 0, 0, 0, 0, 1 till the 1, 1, 1. Isn't it? It starts with 0, 1 till 7. This is the decimal representation. Isn't it? So with respect to that, we need to construct a K-map. In this K-map, I will construct a 8 cell K-map. This is the 8 cell K-map. This is the 8 cell K-map. Here I will take A. Why? Because see, for this condition, if I would have written a completely 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, next is 1, 0, 0. Till here, see, for the first 4 combination, only BC is changing, A is constant. For the other 4 combination, A is constant, only the BC is changing. So that's why I am taking A this side and the BC is this side. Then this is the 0 and this is the for 1. For this 0 combination, 0, 0, 0, 1. Instead of 1, 0, I will write 1, 1 and 1, 0. Why? Because in order to make 1 bit change in the adjacent cell or the neighboring cell. This is a gray code, one which I am using in this K-map in order to make the 1 bit change in the adjacent cell. So now the representation 0, 0 means the 0th cell, 0, 0, 1 means the first, 0, 1, 1 means 3 and this is the 2. 0, 1, 3, 2, 1, 0, 0, 4, 1, 0, 1, 1, 5, 1, 1, 1, 7 and the 6. Are you getting? So here we are using instead of 0, 1, 3, 2. This is the gray code. See, now what we need to do? So we will, I will show you that how to convert the binary to gray. With the help of this also we can easy to interpret. See, binary number, first I will write the binary 0, 1, 2, 3, 4, 5, 6, 7. It is already in the gray representation. See, I will write 0, it's equivalent to 0 only. Okay. And see, for 1, it is 1. For 2, it is 3. For 2, for the place of 3, it is 2. For the place of 4, it is 6. For the place of 5, it is 7. For the place of 6, it is 5. For the place of 7, it is 4. We should come like this. So automatically, we are getting its equivalent gray also. This is one more method I am telling, but don't follow this. The one which we discussed previously, if you follow, that is more than enough. Next, so we will do that. For example, I will take one equation, y is equal to AB bar C plus ABC plus AB bar C bar plus AB C bar. Now, we need to place all the things. First one is A, B bar C. A is there. B bar C is there. Here I will place 1. Next one is ABC. A, B, C. Here 1. Then A, B bar, C bar. B bar, C bar means this is the 1. The next condition AB, A, B and the C bar. A, B and the C bar. Here I am getting 1. See, here we got all the 4 ones in an one line. So I am grouping like this. This entire thing I am grouping like this. So obviously all this combination get cancelled. The remaining is y is equal to A. This is the one combination. For example, sometime there may be a chance I may get here 1. So that point of time, how to write? So in this situation, so I can do the combination. The probable examples I am telling for that time, so I may get one more equation like this. the one more equation, maybe A bar, B bar, C. So that point of time I may get 1 here. I can group like this. This is the second group. So that point of time these two get cancelled. Only I am getting here plus B bar C. This is the equation. So like that there may be a chance of getting, so there may be a chance, so other chances probability I am showing here. So I may get 1 here, I may get 1 here. So what to do in that situation? In that situations, either I can do locking of this corner and this corner. If I lock these two corner, only 2 cells get grouped. If I lock full this 2 and this 2, I am getting 4 cells in group. As I said earlier, as the number of cell increases in a group, number of variable get reduces. So what I will do, so instead of locking this corner, I will lock both the cells of the corner. This one I will lock and this one I will lock. So what I am getting finally, if I lock like this, this is, I can consider as an third group. So then my equation will be plus, so this become, so if I group like this get cancelled and I need to see these two. So here B is changing, here 0 and once it is 1, then only the C bar comes into the picture. So then if I elaborate, say two more entries I have taken here, then this become A bar, B bar, C bar plus, then this is A bar, B, C bar. If I would have get equation like this, if I would have get this equation, big equation, I should first map like this and I should group like this. So finally, I am getting this simplified Boolean expression with the help of 3 variable K-map. This is one. Probably, sometime there may be a chance of, see if I would have written like this, the 8 cell K-map, if there are only 2 ones are there in the corner, so then we need to lock only these corners. If I would have get like this, instead of that, if I would get 1 here, then we can't able to make the corner grouping. Are you clear? So sometimes what happen here, I may get 1, 1, 1, 1, 1, 1, 1, 1, 1 in all the cells. So that time we need to make a complete grouping of the cell. Then we should take y is equal to 1. If all the cells get grouped, then y equal to 1. This is called octal grouping. So in this case, if I would have considered a don't care condition, here also we can possible to consider the don't care condition. While considering the don't care condition, here there may be a chance of getting 1, 1, there may be a chance of don't care, 1, and here I may get don't care. So in such situation, how to tackle the situations BC? So the 0, 1 and this is 0, 0, 0, 1, 1, 1, 1, 0. In this case, I can make possible to group like this. See, first and foremost, we always need to go with the bigger cell grouping. So this is the quad. Then I am getting y is equal to only A plus. Then I will group with these two. And this become B bar, C bar, and I won't consider this don't care. Why? Because I don't want. Why? Because now in this situation I am considering this as 0. So that's why I said don't care, we can consider either it is a 0 or 1. These are all the different possibilities in the 3 variable K-map. Next we will see the 4 variable K-map. Now we will discuss 4 variable K-map. 4 variable means 2 to the power of 4, it is the 16th cell. The 4 variable means A, B, C, D. So AB I will map this side and CD I will map this side. They totally there were 16 cells. Here we need to represent 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. Again 8 starts here. 1, 0, 0, 0, 8, 1, 0, 0, 1, 9, 10, 11, 12, 13, 14 and 15. So here also first I will show how to map. So later we will discuss. Probably there may be a situation like here I may get 1, here I may get 1, here I may get 1. So such situations what we need to do, so we can lock like this. We can lock the corner. So after locking the corner, so what we are getting here, in this A is varying and B is the constant, for this y is equal to, we can write only the b, and in this case 0 and the c is varying, only the d is constant, I can take bd plus there may be a chance I may get here 1 and here also 1. So in such situation, if I do the corner locking of only these two variables, there may be a chance of number of variables more in the term. So instead of that, what I can do, again here also, if I would have do the pairing, this, and finally this is the quad grouping. In this quad grouping, again, this 1, 1 is there, the common, the A I can take, and the B I can't consider because it is varying. Again in this case C is varying, only the D is constant, that is the AD plus. There may be a chance we may get like this. So here also 1, here also 1, then we can able to group all this 4 and all this 4. If we lock, then entire the equation we need to replace because all ones are there, here all ones are there. So then we can say y is equal to, this is the different grouping scenarios I am showing because different possibilities I am showing. The later we will solve some of the examples here, that time you will get to know that clear. Here I am showing only the possibilities. If all these are 1, 1, all these are 1, 1, if I am grouping like this is an octal grouping. Here entire these things get cancelled, we need to see only these two combination. Here C is varying, only the D is there, then I can see y is equal to D. Similarly, see if I get here also 1, 1, here also 1, 1, same thing we need to do. So that point of time we need to log this corners. Then I need to cancel all these things. I need to see only these 2 points. Here A is varying, only B is the constant, so I will get D plus B. There may be a chance of all these are 1, 1, 1, 1. So that point of time we need to group complete whole this 16 cells. Then that point of time we should say y is equal to 1. These are all the different possibilities of mapping and grouping in 4 variable K-map. 4 variable K-map means totally there were 16 cells. Similarly, now we will see how to simplify the SOP expression or the min terms. So this is the one expression. So this expression I need to simplify with the help of K-map. As soon as I am saying this equation, we will get to know that this is the 3 variable K-map we required. 3 variable K-map means how many cells we need? 2 to the power of 3 means totally 8 cell K-map we required. So first we need to construct the 8 cell K-map. So we are simplifying the SOP equation. So 8 cell K-map I am representing here. Then here I am getting A and this is the BC and this is what my Y. And here, so we know that this is 0, 1, 2, 3, 4, 5 and this is the 6 and this is the 7. Now I will map the terms. A, B bar, C. See, this is the A bar and this is the A, and this is the B bar, C bar, this is the B bar, C, this is BC, and this is BC bar. So now what I will do, this is A, B bar, C. A, B bar, C means here is the 1. Next is A bar, B bar, C. Here is the 1. Next is A bar, BC. Here is the 1. Next is the A, B bar, C bar. This is the 1. Next is A bar, B bar, C bar. A bar, B bar, C bar. This is how we got the mapping. So after doing the mapping, we need to make grouping. So here I can do one quad grouping. This is my first group. Similarly, next I will do, this is the second group. This is the pairing, this is the second group. Finally I am getting y is equal to, in this quad, A bar and A is changing. In this case, B bar constant and C bar C is there changing, we shouldn't consider. Plus, after making this pair, so A bar is there, I will consider A bar, and in this case B bar and B is changing, only the C is constant. So for this group, I will take A bar and the C. This is the final equation. Similarly, we have one more expression here. This expression, by seeing this expression again, we will get to know that this is the 4 variable K map. So then 2 to the power of 4, totally a 16 cell K map we require. So I will draw the 16 cell K map. In this 16 cell K map, we know that how to construct the 16 cell K map. So this side I am writing AB and this side is the CD, this is the Y, and I am dividing this. Internally we know that it is having A bar, B bar, A bar, B, AB, AB bar. Similarly this side C bar, D bar, C bar, D, CD, CD bar. Internally this is 0, 1, 2 and the 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and the 15. So after making the mapping, so now we need to map the terms inside the cell. So this is A bar, B bar, C, D bar, A bar, B bar, C, D bar. Here I am getting 1. So next is A, B, C, D bar, A, B. This is the A, B. Then the C, D bar. Here I am getting 1. Then A, B bar, C, D bar, A, B bar, C, D bar. Here I am getting 1. Then A, B bar, C, D. Here I am getting 1. Next is A, B bar, C bar, D bar. Here I am getting 1. Next is A, B, C bar, D bar. Next is the A, B, C bar, D bar. Here I am getting 1. Next is A, B, A bar, B bar, C bar, D bar here. Next is A bar, B, C bar, D, A bar, B, C bar, D. C bar, D is here. So now we need to see how many terms or how many cells we entered. There are totally 8 terms are there here. Now here how many cells? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 cells we have mapped. Now we need to make grouping. So in order to do the grouping, as I said, first as I am making this, so first we need to do the corner cells grouping. See, this corner and this corner, this corner, this corner, I am making a group and I can say this is the first group. In this group, so in this, which is the common term in this? A bar, A is changing, only the common term is B bar. And in this case, which is the common term, C bar, C is changing, only the D bar. So B bar, D bar is the one term. So next what we need to do, I can able to do the corner grouping. So in this I will log this to, this one I will log and this one I will log and I can say this is the second one. So in this case, so which is the common term here, A is the common, B bar is changing, I will take A. And if I see this here, C bar and C is changing, only D bar. So the AD bar plus. So next is what is the next available thing. So in this, finally, this I can't group it anymore. So I will do individual grouping. So in this individual, so I can take, this is the third group I am considering. This become A bar, B, and this is C bar, D. And the last one, in this case, this is one which left out. So how to do this? So in order to do this, see, can I possible to do the grouping with above? No, there is nothing, no cell is mapped over here. So only the final left out is we need to do the pair grouping this. So we need to do pairing. After doing this pairing, then this is my fourth grouping. In this grouping, finally I am getting, so this become A B bar, and in this the common is the C, A B bar C. This is my final equation according to this equation, and for this complete expression, this is the reduced Boolean expression one which we got. Similarly, if I talk about this equation again, by looking, I can say this is again we need a 4 variable K map. Again we need a 16 cell. In this I will take an 16 cell 16 cell K map. In this, I will place A, B, C, D. Again here 0, 0, 0, 1, 1, 0, 1, 1. Sorry. This is 1, 1, 1, 0, 0, 0, 0, 1, 1, 1. Now, I will try to map this. This is 0, 1, this is the 2 and this is the 3, 4, 5 and this is the 6 and the 7, 8, 9, this is the 10, 11, 12, 13 and this is the 14 and this is the 15. So inside we need to make a mapping. So 1 here I need and the 5, 6, 7, next is the 11, 12, 13 and the 15. So the grouping, the mapping is over. Now we will try to do the grouping. If I start doing the grouping, by seeing this, the middle one we can group. This is the first group. So then I can write y is equal to, so in this the common is the B and in this case common is the D, BD plus. Now after that we need to make a grouping. So one more grouping is this. So this is, we can group like this. This is the only possibility. Then this side only the A is the constant and in this case A bar, then this is C bar D plus the next combination, this is the next combination. So in this combination again AB, this side, this C bar is the constant plus. Similarly we need to do the grouping of this two. So in this case A bar B, again the constant variable is the C plus, if I consider the last one, A is the constant and this side BC is, sorry, CD is the constant. This is the final equation for this above the Boolean expression. This is the reduced or synthesized Boolean expression with the help of K-map. Here the one more thing, if we want to find out which are all the essential prime implicants in this particular K-map. What is that? Essential prime implicants. Essential prime implicants. What is the meaning of essential prime implicants? The essential prime implicants means this cell should combine with only one group and it shouldn't combine with more than one group. We'll repeat once again. If any cell combined with only one group is called essential prime implicants. According to this K-map, so which are all the essential prime implicants? See, by seeing this 6 is having grouped with only one group. Similarly, 1 is grouping with only one group. Similarly, 12 and 11. But this 15, 7, 5 and 13 are grouped with more than one group. These cells are grouped with more than one group. So now the 6, 1, 12 and 11 are the essential prime implicants. Why? Because these cells are grouped with only one group. Okay. So which are all the essential prime implicants according to this K-map? 6, 1, 12 and 11 are called essential prime implicants. Remaining all are called essential prime implicant groups. Okay, only the prime implicants, this and all, only the prime implicants. 1, 5, 6, 7, 11, 12, 13 and 15 are called prime implicants. 6, 1, 12, 11 are called essential prime implicants. So the SOP terms are called implicants. Implicants, you should remember that. POS terms are called implicates. Remember that. POS terms are called implicants. But SOP terms are called implicates. Remember that. Now, as such, we have discussed only the SOP equation, synthesis or the reduction with the help of K-map. Now we will see some of the examples, one which related to the POS equations also, and we will see how to group that POS. Now we will see how to simplify the POS equation or the POS term with the help of K-map. As such, we discussed only the SOP terms. Now we will discuss how to simplify the POS equation. So in this case, again, I need a 3 variable K-map. 3 variable K-map means 2 to the power of 3 is 8 cells required. So here I will write only A is enough. Here BC, this is the 0 and this is the 1. This is 0, 0, 0, 1, 1, 1 and the 1, 0. Now I will try to map. So before mapping, we should know that which are all the minterms it is. See, for example, this is the 0, 0, 1. This is, I can say, M1. This is 0, 1, 1. This is the M3. And this is the M7. And this is the 1, 0, 0, M4. And this is, I can say, M0. Okay. So now, if I try to map this, straight away I will map this here. So this will come to 1 position, 0 position, okay, because 0, 1, 2, 3, 4, 5, 6, 7, correct, the 1, then next is the 1 position, next is the 3rd position, then the 7th position and the 4th position. So totally 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So now we need to do the grouping. See, is this the correct one? See, can it be possible to write one? No, because here we are dealing with the POS term. Whenever we are using the POS term, so we need to represent with 0. Instead of 1, we need to represent 0. And remaining, we need to fill with 1, 1. And which is the interested area for us? Now we need to group only the zeros, not ones. So what I will do, I will group only the zeros. See, first I will group this two. Then I will group this two. Then finally I will group this two. There are 3 groups available. So then finally I am getting y is equal to, in the first group, see, these do get cancelled, only the B bar, C bar plus, in this case, only A bar, then the common is B bar, plus, in this case, this do get cancelled, only the BC. First you write like this, but this is not the POS equation. So in order to get the POS equation, first we need to write in the SOP form. In order to get the POS equation, we need to take y equal to y bar. So then this become BC bar, B bar, C bar plus A bar, B bar plus BC whole bar. So from this, we are getting final POS equation. So y is equal to, this become B plus C into A plus B into B bar plus C bar. This is the POS equation. This is how we synthesize the Boolean expression, POS Boolean expression into a synthesized POS form. Similarly, this is for the 8 cell. If we want to do for the 16 cell, this is the 16 cell we required because it contains 4 variable. So here also I will do the same procedure. Okay, in this case, again I will take AB this side and the CD is this side. So here I will take C bar, D bar, C bar, D, CD, CD bar. Again here A bar, B bar, A bar, B, AB, AB bar. So here first I will make the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and the 15. So first I need to make a mapping. So in this mapping, first I will make 1, 2, 3, 8, 9, 12, 13 and 15. So again, is this the 1 or 0? No. Again, this is the 0. We should place 0, not the 1. 1 is for SOP, 0 is for POS. Why I am telling again and again, so you shouldn't confuse with this. For the SOP term, it should be, you should represent with 1, map with 1. For the POS term, you should be map with 0. So in this case, what I will do, first I will make in this 4 are in one group. Then this is this one, these two are in one group. This is the first group and this is the second group. First we will complete. Y is equal to this become A is the common, and in this case the C bar is the common plus, and these two get grouped. In this case A bar B bar is there, A bar B bar, and here the common thing is the C plus here one more. Again these two we can able to group it together, and this is the third one. In this case this become AB, and here the D plus at the end this is, I'm going to be locking like this, the corner, then I'm getting in this the common is B bar and here C bar D bar. This is actually a SOP equation. So I want to convert this SOP equation into an equivalent POS equation as I said earlier. So if I take complement of this, the Y bar, then this become A C bar plus A bar B bar C plus A B D plus B bar C bar D bar whole bar. Then this become A bar plus C into A plus B plus C bar into A bar plus B bar plus D bar into B plus C plus D. This is the POS equation. This is the synthesized POS equation. This is how we can able to simplify or synthesize the POS equation with the help of K-map.